Ever wonder where the trash from decades ago ends up? Most of us don't think about what happens to our garbage after it leaves our homes, but the story doesn't end at the curb. It doesn't vanish, it becomes legacy waste, quietly accumulating in landfills and dump sites across the world. These are massive, unplanned time capsules of past garbage, from plastic toys to hazardous byproducts, and even forgotten household items that tell stories of another era. Old dump sites weren't designed for environmental safety, often lacking protective layers to contain toxins. Many were simply open pits, with no thought given to the long-term consequences. With little documentation, assessing risks and planning cleanups is challenging and dangerous. We often don't even know what lies beneath the surface. Imagine a city's trash over 50 years, all in one place. It's a daunting challenge. The sheer scale is overwhelming, stretching for acres and sometimes blending into the landscape. The out-of-sight, out-of-mind mindset has left us with potential environmental time bombs hidden just beneath the surface of our communities. These sites interact with our environment, releasing substances that poison water, pollute air, and affect climate. The impact can last for generations if left unchecked. Understanding legacy waste is crucial for finding solutions. Only by studying these sites can we hope to prevent further harm. We must acknowledge, study, and clean up this historical problem for our planet's health. It's a responsibility we can't ignore. It's a monumental task, but necessary for future generations. The work we do today will shape the world they inherit. Let's roll up our sleeves and tackle this challenge because the future depends on the actions we take now. Legacy waste poses serious threats to our environment, primarily through leachate, a toxic liquid formed when rainwater seeps through layers of garbage and picks up hazardous chemicals along the way. This leachate can contain heavy metals, organic pollutants, and even pathogens, making it extremely dangerous. In unlined landfills, leachate easily escapes and contaminates groundwater, which is a vital source of drinking water for millions of people and animals. Once polluted, these water sources are incredibly difficult and expensive to clean up. This contamination can persist for centuries, silently threatening water safety for communities, agriculture, and natural ecosystems that depend on clean water to thrive. Meanwhile, decomposing organic materials in landfills release methane and carbon dioxide, both of which are potent greenhouse gases that contribute to global warming. Methane, in particular, is over 25 times more effective than CO2 at trapping heat in our atmosphere. It escapes from legacy landfills, making them significant contributors to climate change. These sites also emit volatile organic compounds and other pollutants, which can cause respiratory problems, headaches, and other health issues for people living nearby. With thousands of dump sites worldwide, the cumulative effect is staggering. These sites leak methane like countless unregulated gas leaks, making the problem truly global in scale. Addressing legacy waste is crucial in the global fight against climate change and for protecting our shared resources. By tackling these neglected sites, we can cut off a major source of methane emissions, helping to stabilize our climate and safeguard our future. Legacy waste is a triple threat. It poisons water, pollutes air, and accelerates climate change, putting all forms of life at risk. Ignoring these sites only spreads the damage further, impacting wildlife, agriculture, and human health across generations. We must act now to turn this liability into an opportunity. By transforming how we manage old waste, we can protect our planet and create a healthier future for everyone. What can we do about hazardous old trash? Around the world, landfills are overflowing with waste that threatens our environment and health. These sites are filled with not just household garbage, but also dangerous chemicals and electronic waste that can leach into the soil and water. Enter biomining, a groundbreaking approach that uses microbes to extract valuable materials from waste. Instead of letting trash pile up, we can use biology to recover resources that would otherwise be lost. Microorganisms like bacteria and fungi act as microscopic miners, breaking down complex waste and turning it into useful resources. These tiny workers are nature's own recyclers, operating at a scale we can barely see. Biomining shifts our perspective, encouraging us to see old landfills as valuable resource banks, not just environmental problems. It's a new way of thinking about what we throw away. This is a core principle of a circular economy, where materials are recovered, recycled, and reused again and again, reducing the need for new raw materials. Unlike traditional mining, which is energy-intensive and polluting, biomining is energy-efficient and environmentally friendly, minimizing harm to the planet. Microbes work at normal temperatures, using natural processes to break down minerals and metals, making the process safer and less resource-intensive. This makes biomining a greener, more sustainable alternative to conventional waste management and mining practices. Its applications are broad, processing mining waste, recovering precious metals from e-waste, cleaning up contaminated sites, and even helping to restore damaged ecosystems. Biomining is science in action, transforming environmental problems into valuable solutions through innovation and research. It offers a sustainable way to manage waste, recover resources, and reduce our reliance on traditional mining. This innovative technology is a true game-changer for the future of waste management and resource recovery. By harnessing nature's power, we can address legacy waste effectively, restoring land and protecting communities. Biomining is a promising step toward a cleaner, more sustainable future for everyone. How does biomining work? It transforms landfills into valuable materials through several steps. First, heavy machinery excavates old waste, bringing it to a processing area. Sorting follows, using magnets and separators to extract metals and separate materials. The goal is to isolate organic fines containing target metals. Microbial treatment, or bioleaching, involves introducing microbes to dissolve metals. These microbes produce acids that release metals into a liquid solution. The final stage is metal recovery, using methods like precipitation or electrowinning. Recovered metals are sold, and treated waste becomes compost or landfill cover. It's a complete cycle, powered by science and nature. Biomining offers an elegant solution to legacy waste. This process is a testament to innovation and sustainability. Biomining is already solving legacy waste issues worldwide. In Alappuzha, India, a biomining project transformed a hazardous dump site into usable land. Curitiba, Brazil, uses biomining to process organic waste, generating biogas for energy. The Ghazipur landfill in Delhi, India, explores large-scale biomining to reduce its massive waste mountain. These projects demonstrate biomining's practical and effective applications. They clean the environment, restore land, and create economic value. Biomining is a powerful tool for building cleaner, healthier communities. With the right technology and commitment, we can undo past environmental damage. These success stories inspire hope for a sustainable future. Biomining is happening now, and it's incredibly exciting. It's a testament to innovation and environmental stewardship. Biomining offers significant environmental and economic benefits. It stops toxic leaching and methane emissions, protecting health and ecosystems. Reclaimed land can be used for parks, agriculture, or development. Economically, biomining creates value from waste, generating revenue from recovered materials. It reduces reliance on finite virgin materials and creates green jobs. Biomining supports a circular economy focused on sustainability. However, challenges exist, such as the slow pace of microbial processes. Optimizing conditions for microbes requires constant monitoring and adjustment. Initial investment costs for biomining facilities can be substantial. Public perception and skepticism can also be barriers. Effective communication of biomining's safety and benefits is crucial. Despite challenges, biomining is a win-win for the planet and economy. It's a promising solution for legacy waste management. For biomining to become mainstream, collaboration is key. Governments can support biomining through policies, incentives, and funding. Companies should invest in biomining, integrating it into business models. Collaboration between startups and industrial players will drive transformation. Communities play a vital role by advocating for sustainable waste management. Public awareness and support for biomining are essential. Biomining is part of a larger shift to a circular economy. We must design products for longevity and recover value from waste. Biomining symbolizes this new way of thinking. It turns past mistakes into resources for a sustainable future. The future is circular, not disposable.